Hello, dear students. So this is our another lecture on these differential equations. And today's topic is about that Bessel differential equation. As you people are already aware about this Bessel differential equation, how to calculate that solution of that homogeneous second order differential equation. And in previous topic, we have discussed about what are basically generating functions, how we are getting the relation between the different coefficients of that j's in this Bessel function is, and those are basically called as these recurrence relation from the generating function. Now, today's topic is about, again, I'm talking about the Bessel differential equation. Now, if you consider some function, अगर हमारे पास कोई function होता है, so if we say that that is basically, we can say that set of functions which basically satisfies that recurrence relation. So if it satisfies that recurrence relation, if we consider some function like z of x, because our Bessel differential equation is that's x square y double dash plus x y dash y that's equal to, right? So this is our Bessel differential equation. And if we consider some function, if we have some function like we have this z of x, तो अगर हम एक function लेंगे, if I if I take some function like z of x, so we need to prove that if this function, the z of x, if it satisfies our basic recurrence relation. So we have already calculated those recurrence relation. If we consider first two recurrence relation by differentiating that generating function with respect to x and then with respect to t. So first recurrence relation is, so if you remember that those recurrence relations were, so that is j n minus 1. So j n minus 1 of x plus, that's equal to, and second recurrence relation was, okay. So these were the two recurrence relations. And तो मैं क्या कह रहा हूँ, अगर हमारे पास कोई फंक्शन होगा z of x if it satisfies these recurrence relations, right? So this z of x satisfies our these two recurrence relation, then we can say that function that z of x is a solution of that Bessel this differential equation, right? So that means we should get some Bessel differential equation if it satisfies these recurrence relation, right? Because as I already told you, I'm saying that we have some z of x which basically that is not given by that just jv of x. So because we know that the Bessel function, how we write that jv of x or jv of x, so that is summation n starts from minus infinity to plus infinity, minus 1 is for j factorial into n plus j factorial into x by 2 raised power that 2j plus n. Okay, so you're already aware about this because we know that. So this is our that Bessel function, and we have calculated that. What I am saying that this z of x को हम y से नहीं लिख सकते. We cannot write z of x in that form, right? Because we know that this jv of x is that is summation some n starts from minus infinity plus infinity minus 1 raised power j factor n plus j. So it is basically we have done that, right? So what I am saying that this z of x doesn't it is not it cannot be written in that form. But what I am saying that if it satisfies these recurrence relation, well, then we can say that z of x will be then the solution for this Bessel differential equation. So that it should satisfy those recurrence relation, this Bessel differential equation, right? So first let us have a look on this. So I'm saying that, so if I'm saying that this z of x satisfies these recurrence relations, so that means we can write that. तो फिर मैं लिख सकता हूँ that z minus 1 or n minus 1. So let's label at that v minus 1 of x So we know that. So if you remember that, so our Bessel differential equation is that is some x square y double dash plus x y dash plus x square minus v square whole of that y that's equal to 0. तो वो हमारी Bessel differential equation. तो हमें देखना है कि we need to check that. So these if I am able to get that this differential equation from these recurrence relation, because I told you that z of x, so then that means I can say that these will be the reconciliation in terms of that z of x, right? Because I am saying that if it satisfies these, right? So then I can write these are again the reconciliation, but in terms of z of x. But that z of x cannot be written in that Bessel function, that jv of x, right? So you need to remember that. Now second is first, because we need to calculate. तो अगर आपको पता होगा, because जो हमारी Bessel differential equation है, that is x square y double dash plus x y dash equal to 0, right? तो ये हमारी Bessel differential equation है. So that means I should get first x square and y double dash, then x y dash plus x square, because I wrote it in terms of v, so it will be then v square, right? So instead of that n square, तो इसको मैं लिख सकता हूँ, it should be then v square, right? So इसको मैं लिख सकता हूँ, so this will be v square, right? तो मुझे basically ये equation चाहिए. So from these two recurrence relations, right? So first मुझे क्या करना है, तो अगर if I have a look, because first I should get the double derivative, second derivative of that z dash of x. तो मुझे कैसे मिल सकता है? So if you differentiate equation, this equation, or you differentiate equation fourth, so you need to differentiate equation fourth first, because that gives me z v double dash of x when you differentiate it. And what I need here, तो और मुझे क्या चाहिए, x square. तो x square मुझे कैसे मिल सकता है? तो I need to multiply here by x square by 2. So first you differentiate equation fourth and then multiply by x square by 2. So after that you need that x y dash. So x y dash कैसे मुझे मिल सकता है? So that I can get again from equation fourth, right? Because equation third में कोई derivative नहीं है, we don't have derivative, or you can differentiate this, there is no issue. But so for simplicity, because it is already written in terms of the first derivative of that z of x, so better is to multiply it by x by 2, because this gives me x z dash, and that's my second term, right? So let's write first two terms, then what will be our next term, let's write that. Okay. So first you can write that differential equation fourth. So that is twice d by dx. So that is twice, okay, and right hand side will be okay, this will be equal to, okay, I am getting now. So पहले मैंने basically get that the second derivative of that function. So because हमारी function जो है that is v of x. Now you multiply it by x square by 2. So when you multiply it by, so when you multiply this equation by x square by 2, it becomes x square okay. Now now our second step is, because I should get this equation, which is basically our Bessel differential equation, right? Because we are saying that z of x, so that can be the solution for this Bessel differential equation if it satisfies the basic recurrence relation. And those reconciliation are basically for this Bessel differential equation, right? So first is that I basically get this x square y double dash. So I'm getting that x square in terms of now z, the second derivative of that z of x, and the second step is that is xy dash. So that means again, no need to differentiate this. Again, simply multiply by x by 2 to equation fourth. So that means equation fourth मुझे, so you can write that multiply by x by 2 to equation fourth. So that's x by 2 into, okay, this will be equal to, तो जो हमारा राइट हैंड साइड है वो सेम रहेगा, only on the left hand side because 2 will cancel, right? Because we are multiplying by x by 2, so it will be x value dash. So that is this term. So next step is, because I need now this sum, this x square minus v square of 1, but y is our z of x, so that I can get from this equation, from equation third. So for equation, so from equation third you need to multiply it by, so because we have this interval that x square minus v square y or z of x equal to 0. So that means I need to multiply here by x by 2 here, right? X by xv by 2. Because when I multiply this equation third by xv by 2, I will get that v square z of x. So that is v square of y, right? Now we have some extra term that is basically this one. So जो extra term है that is x square minus v square. तो x square वहाँ पे है, so that we can see later. But first I am getting now. So you need to multiply equation that. So you need to multiply this, which equation? What is that? So you need to multiply this equation by in order to get that v square. तो हमें क्या चाहिए? V square z v of x. तो v square z v of x हमें मिलेगा यहाँ पे by multiplying by vx by 2. So that means you need to multiply this by, so again you take that multiply so that means जो हमारी equation third है, so let's have a look on the equation third. तो जो हमारी equation third है, that is this one. तो इसको multiply करना है vx by 2 से. So that is, so you can write this as so that is vx by 2. So what is that term? 2v by x. So that's 2v by x. That is 2v by x. Okay. And what else is there? So that is okay. That is v of x. Okay. First let's write, because this 2x by 2 and 2x, so this will cancel. So on the right hand side I will get v square. So v square and this term. तो पहले मैं लिखूंगा that is v square, that is z of x. Okay. Now what's the next step? Because I am getting v square z of x, and also I am getting what is my this x square y double dash means z of x and x square y dash. So that means I need to, तो यहाँ पे मैं ये term यहाँ पे I'm getting this term, that's minus v square of y, because y के बदले हमारा z of x है. So that means I need to add these two equations and subtract the third equation. So I can write this as, so you can write this as, so add this equation, or you can write this equation alpha, and this is equation beta, and now this is our equation that equation gamma. Okay, right. Okay, so you can write this as equation gamma. So you add equation alpha beta and then subtract that gamma from this alpha, right? So that means I can write that add alpha and beta and subtract gamma, right? So first two terms को मैं add करूँगा and gamma में subtract करूँगा. So that means on the right hand side. So let's have a look. So on the on the left hand side, so we have x square z double dash plus x z dash and then b square. So that means on the right hand side, I will get that x square so that will be equal to वो तो राइट हैंड साइड में क्या आएगा तो जस्ट चेक तो राइट हैंड साइड में क्या आएगा पहले x स्क्वायर बाय 2 आएगा फिर x बाय 2 हाँ सो दैट मींस इट विल बी x स्क्वायर बाय 2 into z v minus 1 of x. Okay, so this is this term and z v of x. Okay, so that's first term dash minus z v 1 of dash of x. So this first term plus x by 2 into that so x by 2 that is z v minus 1 of x minus z v plus 1 of x. So ये दो term and then subtraction of this term and minus that gamma. Right? तो जो gamma because यहाँ पे space नहीं है तो better is to write gamma के बदले में लिखना है vx by 2 this term. Right? So I can rewrite this term as, so I can write this as x square z v double dash right. So this is our left hand side. So on our right hand side we can have, so I can combine these terms. I can write that x square by 2 and that okay. So this is our final, right? और इसको मैं लिख सकता हूँ. So if you check that, so I can combine these terms. So इसको मैं लिख सकता हूँ. I can rewrite this as this can be written as this right hand side x square by 2 and inside should be, so that is okay, and then okay, now next term will be minus into v plus 1 by x. Okay, so that this should be v minus 1, sorry. So I did a mistake here. So this should be v minus 1. And this will be v plus 1. Okay. So let's have a look because so what I did मैंने यहाँ पे x square by 2 कॉमन लिया है तो x square by 2 जब हम कॉमन लेंगे तो इनसाइड क्या रहेगा तो ये दो टर्म सेम रहेंगी बिकॉज जो फर्स्ट टू टर्म्स है बिकॉज x square by 2 इज multiplied to first two terms right तो ये मल्टीप्लिकेशन में है इसमें so you can take x square by 2 so inside ये term आएगी now instead of that now we can combine this term so this term we can combine okay so but this is here is no dash sorry there is no dash huh? Right. So okay right now you can combine these terms because you can combine this and this term तो यहाँ पे क्या आएगा तो x स्क्वायर बाई 2 बाहर रहेगा तो इनसाइड क्या रहेगा बिकॉज यहाँ पे v है माइनस v है यहाँ पे प्लस 1 है इट विल बी देन यू टेक माइनस टाइम्स v माइनस 1 बिकॉज यहाँ पे माइनस v है माइनस दिस विल बी माइनस एंड माइनस माइनस विल बी प्लस ये टर्म आएगी एंड स्क्वायर x बिकॉज ऑलरेडी यहाँ की x बाई 2 मल्टीप्लाई था तो हमें और एक x यहाँ पे डिवाइड करना है ताकि वो x स्क्वायर बाई 2 बन जाए राइट because then x and this x will cancel तो ये x by 2 आएगा and basically combine this term and this term and this term and this term right so you can check that because x square by 2 is common to all these terms right okay now we have now one more relation so if you check that Bessel function so we have this Bessel function so let me write that so because we can write this as we know that so we can write this as we know that this jn of x is jn minus 1 of x and second term is or you can shift if you shift that n to n plus 1 अगर मैं shift यहाँ पे करूँगा if I shift that n to n plus 1 तो ये क्या बन जाएगा this is jn of x okay because यहाँ पे मैं shift कर रहा हूँ n to n plus 1 right and similarly we have one more relation that is basically between that okay so okay so one more relation is that is also we have this also we have that twice j dash of x that is j of n minus 1 of x right so this is another Acron's relation right so if you again shift here again you shift that n to n plus 1 is so that means this will be twice dash of x will be equal to right so now if you label this as this is equation a and this equation b right so अब मैं क्या करूँगा I will add these equations so if I add these equations so this equation with this equation so or you can write that this will be okay you can rewrite this as so this jn of x minus jn plus 2 of x it is equal to jn dash jn j dash of n plus 1 of x so you add this with this so ये दो cancel हो जाएंगे so because then you need to add them so you can write that twice jn of x so you add a b तो जब मैं इनको ऐड करूंगा तो ये आएगा twice jn of x will be equal to that is twice j dash of or you can write that because 2 is same everywhere, so you can rewrite this as, so this will be simply that this term, and you can have, okay, so this will be, okay, right. So this is for when you add these equations, right? And similarly, you can get one more relation, that is, you can write that Jn of x will be equal to, so that will be equal to, so you can write this as, so again that will be j dash of n plus 1 of x, and there will be minus this whole system, right? Okay. तो ये कब आएगा when you subtract these two equations. So first जब हमने add दो equations किया, equation first and next, so you are getting this equation. When I subtract, तो subtraction में क्या आएगा? So this will be because on the right hand side, so this will be twice jn of x, so jn of x cancel हो रहा है. So instead of this, I will get that, I will get this relation. Huh? Right. So that means I can rewrite this as, तो इसको मैं लिख सकता हूँ, I can generalize this equation. So I can generalize this equation by, okay. So I can generalize this as, so I can write that jn of x can be written as, so that will be equal to plus minus j dash of n plus 1 plus minus that, sorry, it should be plus here. Huh? This will be n plus minus 1 by x j that n plus minus 1. Because when you add them, तो आएगा पहला यहाँ पे ये प्लस आएगा, and this will be n plus 1 here, it will be j n plus 1 of x, right? तो जब इनको सब्ट्रैक्ट करेंगे इक्वेशन ए एंड इक्वेशन बी को, तो जो हमारी दो इक्वेशन थी यहाँ पे, जब इनको सब्ट्रैक्ट करेंगे उस टाइम पे क्या आएगा? So I will get this as then it will be then minus j dash of n plus 1 of x, and then plus n minus 1 of x j of n minus 1 of x, right? So from these reconciliations, so let's have a look on this equation. So if you remember, if you check that equation, no, this equation, fourth. तो अगर मैं ये check करूँगा, so this I can write as, because this is that jn plus 1 of x, jn dash of n plus 1 of x minus j n plus 1 of x jv n plus 1 of x, right? And this will be that the second term, so that means this will be then twice, right? Because तो ये क्या आएगा? So this will be equal to, it will be equal to x square by 2 into so inside you will get that this will be that twice, it will be minus twice z v of x, right? So using this relation, तो कौन सी relation हमें use करनी है? So you need to use this relation. तो ये relation हमें use करनी है. So when I combine these two terms, so you can write this as, जो जब मैं ये term v minus 1 ये वाली term और ये वाली term combine करूँगा, and this term, right? तो यहाँ से भी मुझे jn of x मिलेगा, zv of x, यहाँ से भी zv of x, but it will be minus twice. So that is this thing. This will be equal to minus that x square zv of x, right? So on the right hand side, what's our right hand side? So that is x square that's equal to this, because जो हमारा right hand side है, left hand side, so that is x square zv w dash plus x zv dash minus this square, and जो हमारा right hand side है, that is minus 2 jn of x zv of x, so that is minus this, right? So if I shift this minus x square on the left hand side, तो ये plus बन जाएगा, right? So that means I can have this relation, that's x square, so which is our Bessel. तो ये हमारी क्या है, दिस इज Bessel function, right? Because so this is it is in that form. तो मैं हमने बेसिकली assume क्या किया था, तो बेसिकली वी assume that अगर हमारे पास कोई फंक्शन होगी that basically satisfies our that recurrence relation, so recurrence relation first and second, so then that can be the solution for that Bessel differential equation, although that function cannot be written in terms of that Bessel function jv of x, but it satisfies that. It can be the solution for that Bessel differential equation only when it satisfies those recurrence relation. So this is what we proved here, because this is our Bessel differential equation. Now let us rewrite this as, so in addition to that we can write what is the, because as I already told you, because we have this regular singular point for this Bessel differential equation. So that means we can or you can say that in addition to that, so that's clear. In addition to that, it basically if it satisfies that Sturm Liouville's problem, so we can construct a set of orthogonal functions from this Bessel differential equation, right? So that means I can make some transformation here. So I will choose that. So we can say that if we choose that, so let us choose. So we choose here that f of rho equal to the degree of k, right? And g of rho we can choose as the degree of L, right? Now, because our differential equation, so let us rewrite this differential equation. So our differential equation will be, so that means I need to choose that x will be equal to k rho, right? Because यहाँ पे मैं क्या ले रहा हूँ, x equal to k rho here, or you can write another function that can be x equal to L rho, right? So first let us choose that x equal to k rho. So in that case, what will happen to this term? Because this will be, so let us rewrite this term. So this is x square equal to 0, right? So this is our Bessel differential equation, and we choose now x equal to k rho. So this will be then, so here जो हमारा differential होगा, this will be d by dx, d of d2 by d dx2 of, or you can rewrite, sorry, so this is, I did a mistake here, so you can write this as d of k rho square. You can write this, or this will be equal to d2 upon k square into d rho 2, because k is some constant, right? And k can be integer, so we are writing that it can be written d2 by k square d rho 2. So that means this equation will be then, because x के बदले हमें क्या लेना है, k rho, so it will be k square rho square d2 by k square d rho 2. Okay. So what basically I did here, तो यहाँ पे मैंने क्या किया है, सो फर्स्ट बिकॉज जो जो हमारा डिफरेंशियल है दैट इज d2 by dx2, बट x के बदले हमें लेना है k rho, because it will be then d2 by k square d rho square, right? And this is what I did here, and instead of x के बदले मैंने लिखा k square rho square d2 by k square d square, right? and this k square will cancel here, k will cancel here, so I can get here because तो यहाँ पे क्या रह जाएगा रो स्क्वायर d2 by d rho 2 this term, then rho here, then this term into that we have k rho equal to 0, right? So I can write this as, so it will be equal to rho square that's equal to 0, right? Or you can write this as because I am multiplying by or dividing by rho square here, तो यहाँ पे rho रह जाएगा, so this will be k square. Okay. Okay. So what I did here, I basically choose here one function that is f of rho equal to z of k rho. So by putting that, by making substitution at x equal to k rho and the differentials भी change हो जाएंगे. So that is basically clear from here. तो आप देख सकते हैं यहाँ पे. So that's clear from here. So ये क्या बन जाएगा because our x equal to k rho. So this will be d2 k square d rho, right? And this is our differential. This is our that Bessel differential equation. And after that, what I did here, you can now because k square will cancel from the first term, then k will cancel from here, and this will be as it is, right? Now, just after that, you are basically dividing by rho square. तो ये टर्म बन जाएगी. So when you divide by rho square, तो यहाँ पे बन जाएगा 1 by rho because rho is multiplying here. Rho is multiplied to this second term, and the third term will be because we are dividing by rho square here. It will be k square minus v square by v square and this term, right? So this is when I did the substitution when I x equal to k rho. So similarly, if I put x equal to L rho, right? So we can have one more equation because if you choose so many other functions that basically satisfies our Bessel differential equation. So we can say that those functions can be a set of orthogonal functions at that point, right? So let us choose some another function. So first function was that's f of rho, or you can write that x equal to k rho, and second we choose that x equal to L rho, right? And so that means we can write now one more equation. Okay. So we can write now. So using that, because we have chosen that f of rho equal to z of k rho and g of rho equal to z of L rho, right? So let us write first equation. If we choose that f of rho equal to z of k, तो ये इक्वेशन क्या बन जाएगी? It will be so let me write that it will be equal to that d2f So this was first equation, and similarly, when I choose that g of rho equal to, right? So this is L here, right? So this is then this g of rho equal to z of L rho, right? So in that case, we have this d2 g of rho equal to 0, okay? Because okay, let me revise a bit. So what I I'm saying now, तो पहले हमने चूज किया दैट अगर हमारी फंक्शन एफ ऑफ रो होगा किसके बराबर, दैट इज आर वी ऑफ के रो, तो दिस और इक्वेशन विल बी दिस, राइट? नाउ हियर बेसिकली वी चूज दैट व्हेन आवर दिस x इक्वल टू के रो, तो यहाँ पे के स्क्वायर आएगा, बट व्हेन आवर x इक्वल टू एल रो, यहाँ पे एल स्क्वायर आएगा, राइट? सो दिस इज अगेन दैट we have two functions, that's f and g, which basically satisfies our this Bessel differential equation. Okay. Right. So okay, so let me revise this. So that means this can be f double dash. तो इसको मैं लिख सकता हूँ that f double dash rho plus okay. Now we can do one thing because I can multiply this equation. तो जो हमारी फर्स्ट इक्वेशन है, तो multiply suppose this equation x and this equation, तो x को मैं मल्टीप्लाई करूंगा किसे, so I multiply it by 0 and y by f, right? तो इसको मैं मल्टीप्लाई करूंगा 0 से एंड सेकंड y को मल्टीप्लाई करूंगा f रो से एंड देन आई सबट्रैक्ट, सो दैट मींस जो फर्स्ट इक्वेशन है, तो जो फर्स्ट इक्वेशन जो बनेगी, सो दैट इज 0 f डबल डैश माइनस and then we have this because so next will be that is a square minus l square into g to rho minus b square by 2. ओके, बिकॉज तो यहाँ पे मैंने क्या किया, तो जो इक्वेशन एक्स थी इसको मैंने मल्टीप्लाई किया किसे, बाय दिस जीरो, तो ये जीरो से मल्टीप्लाई करना है, तो ये क्या बन जाएगा, जीरो एफ डबल डैश एंड सेकंड को इक्वेशन वाई को मल्टीप्लाई करना है एफ से एंड देन सबट्रैक्ट। तो जब मैं सब्ट्रैक्ट करूंगा तो पहले मैंने ये दो टर्म होगा, तो इसको मैंने एफ रो से मल्टीप्लाई, जीरो से मल्टीप्लाई कर, ये बन जाएगा जीरो एफ डबल डैश माइनस सेकंड जो है दैट इज एफ रो जी डबल डैश, तो इन दो का सब्ट्रैक्शन, उसके बाद इन दो का सब्ट्रैक्शन, तो वन बाय रो मैंने कॉमन लिया, तो इनसाइड क्या रहेगा, जीरो एफ एफ डैश माइनस एफ रो जी डैश, सो दिस इज दिस टर्म, तो पहले मैंने ये दो टर्म ली, तो ये टर्म बन जाएगी, उसके बाद ये टर्म मैंने ली और ये टर्म, तो ये बन जाता है and then this term and this term, तो पहली जो टर्म है दैट्स के स्क्वायर माइनस एल स्क्वायर, क्योंकि इसको मुझे जीरो से मल्टीप्लाई करना है, इसको एफ रो से, तो दैट मींस एफ रो जी हमें कॉमन आएगा, तो इनसाइड क्या आएगा, के स्क्वायर माइनस एल स्क्वायर, देन वी हैव द नेक्स्ट टर्म फ्रॉम दिस इनसाइड द ब्रैकेट, सो दैट विल बी माइनस वी स्क्वायर बाय 2 एफ जीरो, बिकॉज़ इसको जीरो से मल्टीप्लाई करना है, सो दैट इज दिस टर्म, एंड सेकंड बन जाएगा बिकॉज़ वी नीड टू सबट्रैक्ट दिस, सो दिस विल बी प्लस, तो ये दो टर्म दिस विल कैंसिल, so this term and this term will cancel. So that means we can have the first, second and the third term that should be equal to 0. So that means we can have that is 0 f double dash minus f. Okay. plus 1 by rho equal to 0. Okay. Now first two terms, तो जो पहली दो टर्म है इसको मैं लिख सकता हूँ, इस वाली टर्म को मैं लिख सकता हूँ, that is d by dx का, इसको मैं लिख सकता हूँ, I can write this as 0 f dash minus f rho g. तो जरा आप जिसको चेक करेंगे whether it is correct or not. So that means, तो अगर हम इसको डिफरेंशिएट करेंगे तो पहली टर्म क्या बन जाएगी, so that will be 0 f double dash plus g dash rho f dash, so this first term, and now second term will be, that will be minus f rho g double dash minus f dash rho g dash. तो ये टर्म बन जाता है, तो अगर हम चेक करेंगे तो ये सेम टर्म है एज इट इज, राइट, बिकॉज वी हैव दिस, and in addition to that we have something outside, so what is that? Okay, let me check that, so if it is right or not. Okay, so so I think it's correct, no? Because I can do one thing, right? uh, Better is to write it. Is it correct? G, that is 0 f double dash uh, plus, because this is okay, so I did a mistake here, so I did a mistake because okay, so I need to expand this term, तो ये मुझे expand करनी है, because here I will get that, तो रो यहाँ पे कैंसिल हो जाएगा, तो ये टर्म क्या बन जाएगी, तो okay, let me write first that, because I basically skip one step here, so let me write that step. So this is, that is 0 0 f dash, sorry, so this f dash, this will be that g f dash minus f. So you can check if it is not possible, I can show you in our next lecture, so how we can, so this whole term इसको मैं लिख सकता हूँ, that is d by dx of so that is equal to, sorry, it is rho, rho, so that is rho g f dash minus g, right? Okay, so if I evaluate this term, if not possible, I can show you in our next lecture, but at least I can write this in terms of this, right? Because time is limited, so I can, maybe I can continue in our next lecture, but for time you remember that I can write this in this, or you can expand yourself, right? So that means यहाँ पे जो instead of this I can write this as, तो ये जो term बन जाएगी, तो इसको मैं लिख सकता हूँ minus d by d rho rho into g of dash minus, so that's equal to, because यहाँ पे मैंने क्या, because ये एक ही साइड में थे, because instead of that I can write that d by d rho of this, and you can take it on the other side, or you can take So this will be the minus type. This will be k square minus l square f rho g. Okay. Now you integrate this equation. So if you integrate this equation between limits a and b, this equation, so you need to integrate this equation between limits a and b in such a way that our left hand side should be equal to 0. So that means I need to integrate this equation from a to b. Okay. So what I'm saying that we need to choose that these limits a and b in such a way so that our left hand side will be equal to 0, right? So that means I can rewrite this as that k square minus l square. This is because L cannot be equal to L cannot be equal to L. This, or you can write this as A to B rho Z of L rho, which is our. So this is our orthogonality condition because k cannot be equal to L. So this is our orthogonality. So in our next lecture, I'm going to first evaluate this term because I'm not sure whether you are getting it or not. So first we need to evaluate this term. So after evaluation, and we need to check one more condition, that's basically condition of normalization. Maybe hopefully we will discuss that in our next lecture. So thank you very much.